So the division algorithm, the official division algorithm looks a little bit long-winded and complicated. It's not really once you get used to it. The main thing is it's an algorithm. It's a procedure that you can go through to divide. And you've done this with integers before, but now we're doing it with polynomials. So let P and D be polynomials with d of x not identically 0. What does that mean? That means that there's at least one value of x where d of x isn't 0. So it's not the function y equals 0, because we're going to divide by it, so we don't want to divide by 0, right? And the degree of d less than or equal to the degree of p, then there are unique polynomials, q and r, called the quotient and remainder, so that p of x equals q of x times d of x plus r of x, with the degree of r less than the degree of d. P is called the dividend, and d is called the divisor. Okay, when r is identically 0, that is when there's no remainder, we say that d divides evenly into p, and we have p of x equals q of x times d of x. So d would be a factor of p of x, as would the quotient q of x, if the remainder is 0. Most often the remainder is not 0, though. But in this case, when the remainder is 0, qx and d of x are factors of p of x. Yeah, I already said that. So that whole thing is a division algorithm. So like I said, it looks a little complicated. So you have to know how to use it. So note when d of x is not 0, that is, when there's a value of x where d of x is not 0, we could, for that value of x, we could divide each term in this expression by d of x. So we'd have p of x over d of x, q of x, the d of x's would cancel, r of x over d of x, which is what I've done here. And this is the form that you're probably more accustomed to seeing this kind of thing in. This is like taking, if you were dealing with integers, this would be like taking what's called a improper fraction, which is a misnomer, and changing it into an integer plus a proper fraction. Okay, so it's the same thing but with polynomials. So it's like 7/2 is 3.5, and with algebra we put that plus in between the 3 and the 1/2, or it means times, right? If you write it out in division form here, you get 7 divided by 2, you get 3, and 3 times 2 is 6. You subtract the 6, you get a remainder of 1. And then you take the 1 and you put it over the divisor, which is 2. So you get 3.5. And you could rewrite that. I don't know how many people remember this, but what this means is 3 times 2 is 6 plus 1 is 7. 3 times 2 plus 1 is 7. That's what this says right here. Now, if the remainder is 0, then 3 times 2, if that was a 6, 3 times 2 is 6. And so 2 and 3 are factors of 6. But it's a 7, so we end up with a remainder of 1. So we've got this 1 sitting out here. Right here.